Hey guys, how are you guys doing? I'm Hero Serrano and I developed the Untold engine, and thank you for joining my channel. Today we're gonna do more debugging. Yesterday we actually started doing some debugging on the latest feature that I added to the engine. However, I ran out of time and had to go to work. Hopefully today I can finish the whole debugging session. I don't think it's gonna take me more than an hour or so. But I wanted to bring you into how I develop the engine, into my thought process, uh, and on and on. Before I start, what I want to share with you is that when you are developing a game engine, always find flaws um, to your own implementations. If you add a new feature to the engine, a new function, a new method, a new class to the engine, um, throughout the day, think on how you can actually break your own implementation, where you can actually find a flaw in your logic, in your thinking, because that is very crucial when you develop a game engine. I cannot say that how important that is. Actually, on Tuesday, when I added that feature where a game character can go up and down the hill, um, I thought it was done, but I knew that there was something in that. I knew that something was not right. And then throughout the day, I thought of, where does the implementation fail? What are the corner cases where my algorithm is going to just, fail? Um, and interestingly enough, as I was on Tuesday when I finished the stream, as I was coming out from my apartment to go to work, I realized a particular issue with the algorithm, that in some instances it's it just it's not going to work. Um, and I want to share that with you because that's part of being a game engine developer, right? Either if you are like a new game engine developer, aspiring one, or a seasoned one, you always need to uh, find flaws in your own logic, in your own algorithms. Don't take that as a bad thing. No, you have to, because if you develop a game engine that is not solid, that is not efficient, then you know you don't really have a game engine. You have nothing, but basically. Uh, and keep in mind that what you're developing is basically the foundation of a game that will sit on top of it, right? So if your game engine is flawed and it's not efficient, well, whatever game is developed on top of it, it's gonna be, it's gonna be also inefficient. So I want to share that with you before I begin. So let me bring up what I actually did on Tuesday. Um, Here's my Xcode. So basically, what we have is this is Blender, and what we have is our character, the terrain, and it's gonna go up, up the hills and down the hills, right? So I exported this to the engine already, so I'm gonna run this so we can actually see how it works, and then I'll show you where is the flaw in our logic. All right. So let me run this, and let me switch my screens to the Mac. All right. So right now everything is building. The engine is actually reading all the attributes and all the data from our character. All right. So now I'm gonna move the character with my controller. So basically, once it approaches a hill, it goes up and down, right? It goes up the hill, and then it goes down the hill. Boom, right? That's basically how everything works. And it seems that everything looks okay. However, there is a huge problem here. Is in our assumption of how we are actually searching through the Octree, right? So I'm gonna copy this terrain because I want to show you something. And I'm gonna go to where I have this guy. Alright, and I'm gonna hide my plane right here for a little second. So what I have here is basically what I built here is basically an Octree composed of axis aligned boxes. So here we have our main root node or our parent box, and then what I do, I divide the big box into 8 smaller boxes. So for example, that's one. I'm going to highlight the other one, 2, 3, 4, 5, 6, 7, 8, right? And basically what occurs is something like this. Let's say this is our terrain, for it as an example, and we build an Octree around it, starting with the parent one, right? Which is the parent one is the one that bounds the whole terrain, and then we keep dividing this into smaller spaces, and more smaller cubes, on and on, until we have 8 of those, and we can keep on going. We can keep on going with the whole subdivision on and on. Right now I'm going from subdivision 1. I can go to subdivision 2, where I will create a smaller cubes, 8 smaller cubes within this cube right here, and you can go on and on and on. And the whole idea is that how I'm able to create for a character to go up and down the hill is basically I shoot a ray. Let's say it's this one. All right. And when I shoot the ray, I test if the ray actually intercepts the particular cube. Okay. And if it does intersect the cube, then I go even deeper, and then I test, okay, does this ray also intercept the triangles that make up, let me hide this so you can see it. Does this ray also intercepts the triangles that make up this plane, right? So here we see that it may intercept it. So this is from the side view. Now from the other view, oh man, where's my ray? This one. Let me get a hold of my ray for a second so you can see it. There you go. Okay, so here's from the side view. Now from the other, from the front view, and you can see here that it's doesn't really intercept it, but I want to just put it here just for the heck of it. So front view intersects it, side view it does intersect it, and then from the top view it does, right? So what I do then is I basically if there is an intersection, I get the normal vector of the intersected triangle, and I use that normal vector in the direction of my character to basically orient my character in such a way that it's going to go up, right, or down, wherever the direction is at. However that character is actually moving. All right, so that's what I do. All right, now this may seem that okay, but that should work, and as you saw here when I ran that project, when I ran the engine, it worked. The idea works, but there's a huge assumption that I made, and my assumption was this. Now what I'm gonna do, I'm gonna bring my plane that I had from when I show you the demo, and let me scale this down to 2 and 0.5. That's my plane right there, and I'm gonna bring up my cube. So in our game, in our demo, what I do is again I have my plane here, and I create an AABB box, axis aligned box, encompassing all of the terrain, and then I keep dividing it, right, into 8 smaller cubes, on and on and on. All right. And then I basically, how it works right now is that I shoot I basically do command. Let me bring this. I want to make it 90. Give me once. There you go. Okay. So what I do is wherever the character is at a particular moment, I simply shoot a ray going downwards, and then I calculate, you know, which triangle is currently hidden, and then get that normal vector of that triangle, and then I change the rotation of the character. That's how I do it, right? Now in this instance, everything looks okay. We're good. But the problem is that what if the ray is being shot from the sideways, right? What if there is an occasion where we want to know which triangle making up the mesh was hit by a ray that is being shot horizontally, right? Now, if we look at this carefully, I'm going to put it here, right? We can say, well, the first thing that we always do is that we test if the ray hits the big cube, and in this case, it does, according to our algorithm. And when it does, we go down the tree, and we now search if the ray hits any of the children of that cube, right? And the children will be these guys, right? So I'm gonna start with this one, right? In this case, it does hit the cube, right? Well, now when it hits the cube, what we do in the algorithm is that we go deeper and we say, okay, perfect. Now retrieve all of the triangles that are within the volume of the cube and test if there is any intersection. All right. So here we test, you know, if there is any ray that is, you know, any triangle that's been hit, and we say, oh no, there's nothing, and we then go out to the next one, the next cube, on and on until we go through the whole every child, right? And that looks okay, perfect. However, what happens when our rays in this particular location right there, okay, we follow the same path, the same logic. Does the ray hits the big cube? Yes, it does. Fine. Now let's check my next cube, right? Which would be this one now, right? And then we test, does the ray hits the cube? Yes, it does. Then okay, well now retrieve all of the triangles making up the that belong to that cube. We get all of those triangles, and now we do a ray triangle intersection, right? But when we do that, guess what happens? We find out that none of the triangles that are within the volume of this cube are actually intersected by the ray. And when that occurs, we exit the whole search. But that's wrong, because the ray does hit a particular triangle in the mesh right here, right? It hits the second cube, the second child here, right? It does hit the second child, right? And it does hit one of the triangles of the mesh. So ideally when we do the test, we should return the triangle that is part of the second cube, this cube right here. In our algorithm, we don't do that. So our assumption is that well, it wasn't even an assumption. It was just, you know, I didn't go through the whole process properly. So we need to fix that, right? So let me bring up my sketchpad here. Now, if you're ever thinking of doing a live coding on Twitch or YouTube or wherever, I have found this tool to be quite cool. Sketchbook, actually. I think it's from Autodesk, if I'm not mistaken. Yeah, Autodesk. And I believe it's free. I don't recall ever paying for this. So just in case you want to use it, either for your, not only for Twitch, but for anywhere else. All right, we have an hour to do this. All right, so let's recap what I talked about. So I have my root node here, okay, and then I have my parent, and then I have imagine we have 8 here, okay, and then this guy may have other children. All right, in every of these scenarios, what we do is we do a test between our array and a cube. Okay, so our search starts like this. We go from the parent and we do the test. Does the array hits the parent? Yes, it does. Then we go to the next one, right? And then we go and say, well, does the array hits the this particular cube? And in this case, we may say, oh no, it doesn't. So then we go to our sibling, right? And then we do that test here. Let's assume that it does in this case, that there is an intersection between the array and the cube. Well, in that instance, what do? We go down the tree, and now we do a test with one of the children, right? And now in this case, let's say that we do have a test here between the array and this smaller cube. And say, oh, well, there is. Well, if that's the case, then what I want you to do is I want you to test an intersection between all of the triangles that are stored in your node. Let me bring it up. And then return the normal or the triangle that was intersected by the array. So once I get to this point, I go and say, okay, now let me check for an intersection with my triangles. If I don't find anything, right? Let's say I don't find anything. My algorithm basically just said, well, there was no intersection at all. That return false, and I will get out. Well, not quite, because as you saw in this example right here, we should still keep looking. So what we should do is that we should either we should get out from here, say, okay, fine, no, I couldn't find anything here, but let me see if the array intersects this guy, and probably it doesn't. Okay, fine, let's see if it doesn't intersect this one, and say, well, this one does intersect it. Well, then now go and search the triangles, and if there's no intersection here, well, we need to go back to the parent, right, the other guys, and check which one actually has an intersection, and make sure and double check which one has it. Now that reminds me of something else, right? Doing this, right, making sure that we are actually testing if there's no another interception will fix the problem that I just explained to you. However, it's not going to fix another flaw in our logic. This is what I'm telling you. If you want to become a game engine developer, you need to go deep into your own implementation and find every possible flaw that you can think of. I usually have a notebook where I write basically, I come up with a bunch of stuff, like ideas, or like I do a lot of I'm not artistic at all, but I do a lot. I don't know if you can see that. Can you see that? Well, I don't know if you can see it, but I do a lot of sketches, And basically, I bring all of the algorithms into a way of how I can visualize it and find, anything that I probably didn't think of. Well, the other problem is that, let's say that we fix that and we actually go, and we keep searching for another node that may be having intersection. Well, if you notice something here, at this point, I can actually return two different triangles, right? The triangle that is here, right? Or the triangle that is over here, because both of these triangles are actually hit by the rays. So let me see if I can highlight it. There you go, right? Both of them. And I need to make sure that, which one is the correct one? Which one do I return, right? So as I'm doing the whole search, not only do I need to keep searching if there is any other intersection between the ray and the cube, but I also need to make sure that if I find an intersection between the ray and a triangle, to keep a note of that triangle and put it aside, and whenever I find another intersection with another triangle, compare it and basically compare the distance between the origin of the triangle of the ray to the intersected triangles, and return the closest triangle to the origin of the ray, right? For example, let me put it like this. This is my ray here, right? And this is my origin. I'm sorry guys, I'm so bad at this. God damn it. And this is my origin. Let's say I have two triangles here that I found, right? Ideally, what we want is we want to get the closest triangle, right? And not this one, not that one, right? Because we're hitting this triangle first. But there's something else that you need to think about. What we want is the triangle that has a normal basically pointing in the opposite direction as the ray. This guy may be pointing that way and this guy may be pointing that way, right? What we really want is ideally what we want is the ray that let's see, let me call it this a vector, okay? And I'm gonna put this as distances basically. All right, what we want is the triangle whose the direction of the ray and the normal vector of the triangle is basically less than or equals to 0. That product between them two, right? And you can actually see it here, right? If this is my ray moving that way from here that way, this particular triangle, the norm of that triangle is basically pointing the other direction as the ray direction. And if you get that product of them two, well, that's going to give you, should be less than or equals to 0. The other triangle, which is on the other side of the mesh, that product between that normal vector and the ray is going to be greater than 0. So you need to keep that in mind. We need to get also the closest direction, the closest distance to the ray origin, and also that normal vector needs to be in different direction. All right. So basically, that's what I wanted to show you, right? I actually Before I say that, let me explain this to you first. So basically, this is what I wanted to show you, and this is what I basically worked on yesterday. Um, I simply just kept instead of returning getting out once I find a possible intersection. I don't do that. I keep on searching for a better one, and not only that, but I also keep keep like a keep a log, right, of the distance of the triangle, and if I find a better triangle with which is closer to the ray origin, then I use that instead. I also check for the that product between the direction of the ray and the normal vector, on and on and on until I find the best one, right? And now let me bring up the code here because that's what I did actually yesterday. Um, this is the whole code section that basically does the whole search, which is basically the whole search that I'm doing here, right? And here, once I go into a leaf node, I retrieve the triangles. Then I do a ray versus triangle intersection. If there is an intersection, what I do is I get a distance between the triangle and the ray origin. Then I get the normal of the intersected triangle, the normal vector of the intersected triangle, and then I basically do a test, right? I test if the triangle is closest to the previous triangle, and if the normal vector between the ray origin and the ray direction and the triangle normal is less than or equals to 0. And if that's the case, then I basically store those values and I don't get out. I just keep on searching for for a better one. All right. Now I actually found, again, I was at work and all of a sudden it hit me. I'm like, yeah, that works, but there's another problem. Once you get to this point where once you get to this point, I'm forcing myself to go to the next child, right? And I don't do a test between the ray and the cube at this point. I simply just go and retrieve the triangles. Well, no, I need to also do a particular test between the ray and the cube at this point, right? I do not want to be searching for triangles when I know there's no intersection between the ray and its parent node. So right now I need to actually add that. So I'm going to add that, and then I'm going to do a test, and let's see how everything goes. And I cannot believe I didn't have music on for you guys. Alright, let's see. Alright, let's add that. So here basically what I'm gonna do a ray versus intersection, and that should do it. Oh, I think I can fix this, make this a lot better actually. Alright, I'm gonna move this guy out because it shouldn't be there, because I'm gonna use it also for my leaf node here, right? Okay, now for my leaf node, I'm gonna basically do a test, which would be basically the ray. So I can just basically copy this. And I can do that here. Obviously, that's not what I want. Here, if there is a ray versus in the cube intersection, what I want to do all of this tests right here that I have right here. And I hate when I have to figure this out. That's that one. And I'm assuming this is for the for back. Yeah, alright. For the for loop. Alright, so I'm gonna put all of this guy in here. So basically, if AABB versus ray intersection is true, then we go and search. This one with apparent, I just do the ray intersect blah blah blah. And I don't think there is anything else. I intersect, I check, I go for the next one. That should build fine. Let's see. Alright, now let's do a test. Alright, we're gonna go very simple. We're not gonna use this plane right here right now because that is too complicated. We're going to use this plane right here. And we're gonna use this ray. Well, it's a line actually. And first of all, we are going to test if this works. Alright. Do I have this triangulated? Okay, so in our initial test, what we're going to do is we're going to test the ray that hits this particular triangle. Alright. And we should actually get the location for that triangle, just to make sure that we're good. Then we're going to be doing some more tests on and on and on, and hopefully that should fix it. Alright, so let's do this. Let me export this to the engine. Now let me also I'm going to comment out the section where I create the astronaut, because I don't need it for now. My plane, and I'm also going to remove the section where I create some of the game assets, such as the trees and all of that. All right, now this is the section where I do the test with my ray and everything else. All right, so my ray origin is this guy. Let me see, where do I begin? Okay, I'm gonna use this point right here as my origin. Okay, so it's 1.3 point. This is 1.3.29 and 0.10. All right. So now what I should be getting back is actually the position of this intersected triangle. This one, come on, that one. I should get in a value around the 0.8, 0.06 and 0.2. That's what I should be getting ideally. So let's see if that happens. If that occurs, then we're good. If not, then and look at the values, boys. I get 0.8, which is 0.8. I should get 0.2, 0.2, and 0.06, 0.06. Um, and the normal vector, actually, if you see it here, this is where I'm actually getting the data in the output window. My normal vector obviously should be pointing, positive x 0.2, positive y 0.06, and 0 along the z-axis. All right, cool. Now that works. Now let's move this guy. Where should we move this guy? Oh, you know what? All right, I have an idea. Is it possible for me to actually bring this? Let me see if I can actually bring this guy up. Boom, that guy up. There you go. Okay. Now let me bring up the array over here. I want to hit that guy right there. Boom, 7. All right, now with this new okay, with this one, then I believe I should be hitting that one. Yeah, I should be hitting that ray right there, that triangle. Actually, let me move a little bit to the side. Okay, so yeah, I should be hitting this triangle. All right, so for that one, I should be getting this value. Okay, cool. Now let me export this, so or else I'm not gonna get the right my right data. Okay, now for my ray, my position is gonna change 1.3, 0.76, and 0.18. All right, let's see. Ideally, we should be getting that triangle, -0.0, -0.3. And let's see. If that works, then it means that we actually did our whole search properly. If not, then we need to double check. And we did get the right value. We get 0.3, 0.3, which is you can compare it with here, and then 0.06. So there you have it. That works. Cool. Let's do one more. Let's do one more because we need to make sure. How can I mess this up a little bit so I can get like a different hey, let's do it like this. Let's do this one. Let's get this one. Let's raise this one up. All right, and let's get my rate D here. Control 3. I want you to hit that one, and 7. All right, cool. So now I believe I should be hitting this one if I'm not mistaken. Yep, that's my ray. Control 3. Can I get my I'm looking for my ray, making sure that it's gonna hit it. Okay, so should hit that one. Yep. Okay, cool. Now let's get my ray. Since I changed the whole shape of my plane here, I need to export that new shape, or else I'm not gonna get anything. Okay, now my ray, the position is negative 1.9, then 1.3, and negative 0.84, and then my direction now is actually going in the positive x direction, so I need to change that too. Alright, so ideally we should be getting this guy, that value, negative 0.06, 0.866, on and on. So let's see. And ladies and gentlemen, I think we got it. If you look at the values here, we get negative 0.06, negative 0.06 here, 0.13, which is 0.13, and 0.86, 0.86. So, yep, we're good. All right, everything seems to be working. However, we need to do a big test now. Now the test that I think we should be doing is something like this. Watch. I'm gonna go back to this guy right here. That one. And now I'm gonna delete this plane for now, and I'm gonna hide the trees. And I'm going to create a mesh at an icosphere. Okay, where did you go there? This one. Jesus, god damn it! I hate when that happens. Let me delete it. I'm gonna create the icosphere here, and I'm going to actually add one more subdivision to that. Now let me scale this, because I'm gonna make some kind of like a world here, like an Earth. All right. Now let me scale everything to 1. All right. What I'm gonna do, I'm gonna set that my let me get a hold of this astronaut right here. Okay, the test that I'm gonna do, and I obviously haven't tested this out at all, so I do not know if this is gonna work. But ideally, if we do something like this, then this should give us the proper value or data that we want, right? And I'm gonna set that the guy over here. Okay, so now when I basically make the move my character, the astronaut should actually go around the whole sphere. That should ideally work. If our algorithm works, this should also work. Now my demo, when I wrote my demo, I didn't wrote it to go around the sphere, so it may be a little bit off when the character goes around. But as long as the character seems to be changing directions, that's all what we really care, all right? So don't be too tough on me if this doesn't work, all right? Okay, let me do something else here so that way we can actually see all of this working properly. This is the fun part of working with a game engine. You get to put your artistic talents into practice. And even if you don't have any, like I do. All right. Oh. So I'm gonna get all of this guy. Come on. I'm gonna add a texture actually to the whole to everything, and I'm gonna make this bluish. I don't like the blue. All right. Actually, let's go a little bit. Why am I actually? There you go. All right. What I'm gonna do. Is that I'm gonna get some of these guys. And some of these guys right here. And these guys right here. And basically I want to make them some kind of an island or something. Alright, now let me unwrap these guys. Alright, and I'm gonna make these guys actually be kind of greenish. That. Alright, so if I do have some textures to it, you guys will see it's gonna look kind of that texture. I like that, right? Cool. Alright. Alright, let me call this come on, get out of here. Let me call this yeah, let me call this what was the name that I gave it? Plain. I'm gonna call it plain, just for the heck of it. Alright, then I'm gonna export this. Alright, let's see if this is gonna work, guys, because I do not know if this actually will work. But it will be fun to see it work. And that will also tell us, hey, the algorithm now is solid enough that it can detect things like that. I didn't add the trees. I'm not gonna add it right now because I need to see if it works first. Okay, I'm turning on my plane. Astronaut is working. That is working. All right, sweet. Let's do this, boys. Okay, now I'm gonna switch to my Mac screen, so you can see my Mac. Alright, let's see if this works, guys. I have no idea if this is gonna work. Alright, so... Oh, look! Damn! Okay, you see that over there? Probably the... Okay, let me run that again. When we went down on the other side, on the... to the other side, it didn't it started to just fly off. So I wonder if there's an issue with that particular okay, look, no, it works. Okay, so if I go around and if I come back, then I should be okay, right? Come back, there you go. Okay, well, like I said, that when I wrote that demo, I didn't intended to write it for this, so you know, don't look, it goes, it does tilt, it does. Okay, all right, Okay, let me do it there because I wonder if that may be an issue. I actually like my earth too, by the way. Okay, should be coming up. There you go. Yep. So it seems that it works. It is flying off a little bit away from the earth, but again, I didn't write the demo to do that, right? So that is the issue. Now let's get a little bit artistic. Let me move these guys out over here. And I'm gonna do another test now that I thought about. Let me bring this guy. Okay, now I'm actually I'm gonna bring my. I'm going to add my trees to the to the world. Okay, just for the heck of it, just to make this cool. Haha. No. Let me add this one somewhere. I don't know, around there. And this one should be rotate this around that my Y by 90. There you go. I'm gonna put it here. Again, doesn't matter, just as long as it looks nice. Oh yeah, and I need to rotate this. This one, rotate this Y negative 90. Boom. This is one of the things that you need to keep in mind if you're going to develop a game engine. You are going to put some of your artistic skills to practice, right? You have to. It's fun though. I ended up watching a lot of YouTube videos actually that taught me how to use Blender and a lot of 3D modeling. I know you may be thinking, well, you know, you want to be doing coding and all everything like that. I'm like, yes, you do, but you need to keep in mind that if you're going to develop a game engine, it's not only about coding; it's also about understanding the workflow of artists, of the game artists and the designers. So you need to keep that in mind. It's not just coding. You really need to understand. You need to talk the artist language as well as the game developer language, right? Because you are the one that sits in the middle, right? The game artist develops the characters, the game developer makes them come alive. Well, how does that happen? Is through the game engine. So you need to really be in both worlds, understand both worlds. You don't have to become an expert in how to model a 3D character, but it helps to know the workflow. Alright, so that is that. Alright, let's export this now. And one more thing that I noticed. Alright, I'm going to actually move my camera out a little bit. To 30. Alright, so okay, let's do this, guys. Let me switch to my other screen, my Mac. Oh, this is building. There you go. All right, let's do this one more time. It's going around. Perfect. And it should come up anytime, any moment now. All right, now let me switch it that way. And now it should really go around. Yep. I think this works, guys. All right. Now you obviously can see that slowly it's actually getting it seems like it's shooting off the earth. Again, that's part of the demo. I did not really intend to have something like this right now, so forgive me. It's the demo, it's not the engine. The engine seems to be working now. Right, you see that? How I switched things off. So let me do one more test. I want to make sure that that's what it is. Alright, so I'm gonna switch this guy and I'm gonna make it move forward. And I should be getting something on the other side. Alright. Now if I go here, let's see. It goes around. And I should be getting it back. Alright. I know it's not perfect, but the whole idea that we are intersecting shooting array and getting the triangle and the normal is there. It actually works. We basically fixed that issue, so you know, I think we're good now. Let's see. Well, alright guys, I think this is gonna be enough for today. I actually wanted to fix that bug with you because one of my goals with my Twitch channel is actually to bring you into my whole thought process and share with you the whole development of the game engine live, right? I want you to see how I use the tools such as Blender, you know, how I use Xcode, basically my whole logic, my whole thought process. So one more thing that I want you to keep this in mind. Game engine development is not something. It's not a sprint. It's a marathon, right? And how I managed to develop a game engine all by myself is that I would implement a feature for the engine, and I didn't become demotivated because that particular feature was not working perfectly, right? I knew that you know, I know my limitations. So what I would do is that even though that feature didn't work perfectly at that moment, I implemented it to the point that it was good enough, just good enough, so I can keep on going with the other components of the game engine. And as time progressed, I gained more knowledge, right? And then I would come back to that particular feature, and with my new gained knowledge, I would improve it. And again, I would improve it to the point that it was like, okay, you know, this is getting way better now. You know, it's not perfect, but it has improved a lot. And then I would go on and develop other components of the engine, and my knowledge will increase in other topics, and then I will come back. So the whole game engine, the whole development of the engine has been basically an incremental process. It's been little by little, little by little. Um, you know, Components in the engine that I developed 3 years ago, they don't compare to what I have now. Uh, and it's not because I'm really good at programming. I am not. It's not because I'm a good engineer. No, I am not. Um, it's all about having this mindset that I may not have something perfect right now, but I will have it soon, and I'm gonna work on it. I'm gonna study. I'm gonna learn, um, and eventually everything will just improve, make sense, and you get better and better and better and better. For example, right now, this new implementation that I did with the using an Octree and the RayCast to determine when I should move the um, my character to go up or down that slope. It may not be perfect right now. I can assure you it is not, because I'm looking through the code that I have. It's a little bit sloppy, but that's okay. It's normally okay. It's totally okay. Just keep on moving. Eventually, you're gonna come back to that same um, code snippet, and you're gonna see some flaws. Like, hey, I can do it like this better. I can do it like that. So don't worry. Don't worry if your game engine right now is not what you want it to be. It's an incremental process, and that's all what you need to be thinking of. That should be your mindset. All right. So guys, I think I'm gonna be live again tomorrow. I believe like around 11 a.m. Mountain Standard Time. So I hope to see you there. If you have friends that may be interested in knowing more about game engine development, let them know about my channel. And if you haven't subscribed to my channel, hey, please do so. Tomorrow I'm gonna do more debugging on other stuff that I knew there were some flaws in other parts of the engine, and it's time now for me to fix them. So I hope to see you tomorrow, and I will definitely be here on Sunday also. Okay guys, thank you for joining my channel. I'll see you then. Bye.